So for this problem, you have a cone that is truncated. Z is between 1 and 6, and that's the formula of the cone. The first part is asking, give a surface parameterization for this cone. Let's figure this out. What I have is a cone, right? Let's write it this way. I like it better this way. That's the original. I can think of if Z was a constant, then it would be appropriate to have X equal to Z cosine T and Y equal to Z sine T. This is just two parameters. So Z equal to Z would work as well. So, I mean, the parameter's name can change, but that's the basic of it. So I can write G of Z and T to be this thing, and Z cosine T, Z sine T. And Z, I have to be careful. Z has to be between 1 and 6. Now, part B is asking to compute G sub R cross G sub theta. Oh, parameterization is actually asking us to replace this. Let's replace that. G of, instead of that, G of R and theta. So I get R cosine theta, R sine theta, and R. And R is between 1 and 6. Now, let's compute G sub R. And G sub R is going to be cosine theta, sine theta, and 1. G sub theta is going to be minus R sine theta, R cosine theta, and 0. And then G sub R plus G sub theta is going to be equal to negative R. The sine theta, then covered, that was the cover, negative R sine theta. Now, if I cover the middle one, I call cosine, negative cosine times cosine theta times 0, then negative, 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 positive, and I get R sine theta, and then, negative, negative, minus. There were 3 negatives involved. And then I will have the last one is R cosine squared theta plus R sine squared theta. And we know that we factor this and it's going to be R, basically. So what I have is minus R sine theta, R. My apologies, there was one error happening here. When I covered that, it was R cosine theta. So R cosine theta minus R sine theta and R. The next thing is saying compute the mass of a thin funnel in that shape, truncated cone, when rho is 5 gram per unit. So this is, if I'm computing mass, it's a scalar surface integral, because this is a scalar function. That 5 is the scalar function. So let's find the scalar surface integral. And scalar surface integral is going to be what is here, theta is between 0 and 2 pi. So 0 to 2 pi, 1 to 6, and the integrand is 5. And I have to find the magnitude of G sub R cross G sub theta. which is going to end up to be r squared cosine squared theta plus r squared sine squared theta plus r squared. The first two are going to be just r squared plus r squared. So square root of 2r squared. R can come out because r is positive. It doesn't need absolute value. I get square root of 2 times r. And then dr d theta. And then I compute this, and it's going to be 175 square root of 2 pi. So that's all good. Let's try to do the last part. And let's remember that is the minus r cosine theta, so g sub r. For d, remember g sub r cos g sub theta is negative r cosine theta, negative r sine theta, and r. This one says find the flux in the direction shown of that vector field. The direction r z is negative, it's going downward somehow, and x and y are positive for this vector. So I have to find n, I have to multiply this by a negative sign. And that's it. And then f, find a g, which is going to be r cosine theta, r sine theta, and negative r. If I dot the two of them together, I will end up with r squared cosine squared theta plus r squared sine squared theta plus r squared, which I just computed is 2r squared. And we integrate again from 0 to 2 pi, 1 to 6 for r, as we did before, 2r squared. And the final answer is going to be 286.67 approximately pi.